Solutions for tiling to Anhydrite Screeds.
Norcross Adhesives is part of the Norcross Group, and alongside sister company Johnson Tiles, it is based at the heart of the UK ceramics industry in Stoke-on-Trent. The company is a leading British manufacturer. The product range includes branded adhesives, grouts and surface preparation products for fixing ceramic and porcelain tiles, mosaics, natural stone and marble. Quality is vital to Norcross Adhesives, so only the finest raw materials are used, along with increasing proportions of recycled materials. Strict quality control checks are performed on all incoming materials upon delivery. The modern, fully automated manufacturing and packaging plant employs lean manufacturing techniques for the high-volume production of polymer-modified powder adhesives, grouts and screeds, together with professional performance ready-mixed adhesives. Once the products are manufactured, the extensive care doesn't stop there. Each batch is individually tested, and high-tech machinery seals and palletizes each bag. Investment in state-of-the-art machinery at all stages of the production and packaging process enables Norcross Adhesives to manufacture, package and distribute technically advanced products within very precise manufacturing parameters, and with a minimum of wastage and environmental impact. Norcross Adhesives takes its environmental responsibilities seriously and is ISO 14001 accredited for reducing waste and improving resource efficiency. Norcross Adhesives continually refines and develops its product range, improving existing products and adding innovative new ones. The company's future growth comes through continued innovation and rigorous R&D to create the next generation of adhesives. This is the way Norcross Adhesives keeps one step ahead of its competitors. The company's recent investment in a new skills centre allows for the delivery of a wide range of practical courses for tilers and retailers, giving real insight into product development and installation techniques. In this way, investment by Norcross Adhesives is benefiting the industry as a whole. The Skills Centre enables Norcross Adhesives to deliver REBA-accredited CPD courses, which are a welcome resource for architects, helping to drive up product knowledge and technical expertise within the industry. As well as theoretical training, students also get the chance to try out practical skills that they have learned. Exceptional training support is at the heart of the Norcross Job Done ethos. The Technical Helpline is a one-stop resource for advice and support on products, system installation and more. Site visits, technical reports and remedial advice are always available. All Norcross products come with a lifetime guarantee. It's the company's promise to the industry. It all adds up to a success story in manufacturing, sales and distribution for Norcross Adhesives. It is the one-stop shop for high-quality, British-made products.
The learning aims of this seminar are to understand the differences between sand cement and anhydrite screeds, as well as the advantages and disadvantages of both. The processes for installation of each type of screed with regard to the relevant British standard, subsequent drying and preparation of the screeded surface prior to the application of tiles, the sealing of the screed and application of the correct tile adhesives for use on anhydrite screeds, and being able to specify a safe, guaranteed industry-approved system which allows fast-track fixing to anhydrite screeds. During the course of this CPD, we will be looking at the relevant standards, the types of sand cement screed, what an anhydrite screed is, the advantages and disadvantages of anhydrite screeds, the advantages and disadvantages of anhydrite screeds, how to identify an anhydrite screed, surface preparation, adhesive classifications, solutions for tiling to anhydrite screeds, case studies. We will then finish the CPD with a summary of what we have covered and the expected learning outcomes, followed by some recommendations for future reference. The British standard regarding the application of anhydrite screeds is Part 7 of 8204, titled Pumpable Self-Smoothing Screeds. This standard specifies requirements such as soundness and level tolerances. These types of screeds are referred to in BS-EN 13813, titled Screed Material and Floor Screeds. They are also referred to in BS-EN 13892, titled Methods of Tests for Screed Material, and BS 5385, titled The Design and Installation of Internal and External Ceramic and Mosaic Floor Tiling in Normal Conditions. NBS Publications Section M13 also applies in the installation of anhydrite screeds. A sand cement screed is made up of Portland cement of strength class 42.5 newtons and dry aggregate, ensuring that due allowance is made for the moisture content of any damp materials used. If cement of other types or classes are used, then the mix proportions might need to be adjusted in order to achieve mixes of similar strength characteristics to those recommended. The mix proportions for a leveling screed should be within the range of 1 part cement and 3 parts sand to 1 part cement and 4.5 parts sand by weight. If fine concrete is being mixed, the cement to total aggregate ratio should be between 1:4 and 1:5 by weight. Wherever the leveling screed is required to be 50 mm or greater, then fine concrete should preferably be used. The minimum water required to give sufficient workability for laying and thorough compaction should be used. There are different types of screed construction. Bonded construction is where the screed is laid on a prepared concrete base that is protected from rising damp. This will permit the minimum screed thickness of 25 mm to 40 mm, but is seldom used because, for a small increase in thickness, an unbonded screed can be laid without the need for preparation. In an unbonded construction, the screed sits on a separating membrane. The separating membrane is typically a polyethylene sheet with a minimum of 500 gauge thickness. This will remove the need for base preparation and can prevent wet screed from flowing down holes and gaps in a base, particularly a precast plank or beam and block base. For bases without protection against rise of groundwater, a DPM should be provided under the screed. An unbonded screed can be laid at a minimum thickness of 50 mm. The screed may be laid on insulation to provide thermal insulation, impact sound insulation, or a combination of both. A polyethylene sheet membrane should be laid over the insulation to prevent the screed mortar flowing under it. This sheet can be of DPM grade if a damp-proof membrane is required. In domestic installations, a floating screed should be a minimum 65 mm thick, with a minimum 75 mm thick screed being required in commercial installations. What is an anhydrite screed? An anhydrite screed is a mix of fine and coarse aggregates with a calcium sulfate, otherwise known as gypsum, or calcium sulfate dihydrite binder. It is sometimes referred to as a calcium sulfate screed, flow screed, or a gypsum-based screed as opposed to a sand cement screed as discussed earlier. Both types of screed are intended to provide a smooth and level surface onto which tiles or other floor coverings can be laid, because floor substrates are rarely level and smooth enough to accept tiles or floor coverings directly. Anhydrite screeds are not wearing screeds and are designed to receive a suitable floor covering such as tiles and soft floor finishes. When mixed and applied correctly, anhydrite screeds will last a lifetime. However, they are water sensitive and must therefore not be used in areas where they may be subjected to moisture ingress unless suitable tanking membranes are used. Anhydrite screeds are liquid screeds that are pumped into the installation. They flow to cover the floor and will encapsulate underfloor heating pipes. They can usually be trafficked after 24 hours. As with sand cement screeds, anhydrite screeds can be bonded, unbonded, or as a floating screed onto dense insulation. A bonded screed is laid onto a prepared concrete base which has been primed and sealed with an SBR, acrylic, polyurethane or water-dispersed epoxy primer, in line with the manufacturer's recommendations. It can be laid at a 25 mm thickness. As with sand cement screeds, there is a risk of wet screed flowing down holes and gaps in the underlying slab. An unbonded screed is laid onto a separating membrane and can be used as little as 30 mm thickness. A floating screed is laid onto dense insulation. The minimum required thickness is 35 mm in domestic installations and 40 mm in commercial installations. Anhydrite screeds also experience minimal drying shrinkage, with a low risk of cracking or curling. Therefore, bonding to the substrate is not normally required, and gypsum screeds can be laid significantly thinner than traditional cement-based screeds. As can be seen from the table, an unbonded sand cement screed must be a minimum thickness of 50 mm, whereas an anhydrite screed may be laid as thin as 30 mm. When laid as a floating screed, an anhydrite screed may be laid 30 mm thinner than a conventional sand cement screed, meaning that in domestic areas the anhydrite screed needs to be only 35 mm thick and 40 mm in commercial areas. This provides a big advantage in areas where floor height needs to be kept to a minimum. Anhydrite screeds were introduced over 2 decades ago, and they have enjoyed a rise in popularity in the building industry over the last few years. They have a number of benefits over sand cement screeds. Traditional sand cement screeds can be slow and labour-intensive to install. Anhydrite screeds are substantially quicker and easier, as they are pumped and flow to find their own level. They are more cost-effective than traditional screeds. For example, on ground floor installations, anhydrite screeds are an average of £2 to £5 per metre squared cheaper to lay than sand cement screeds. Anhydrite screeds will self-level and offer minimal shrinkage. They offer high strength between C20 and C35 and are also convenient for use with underfloor heating. Anhydrite screeds have a fluid consistency and can be easily pumped onto sites. This means that large areas can be laid in short time and the encapsulation of underfloor heating pipes is improved. When you see that up to 2,000 square meters of calcium sulfate screed can be laid in a single day, compared to 100 to 150 meters square achieved with the conventional sand cement screeds, it's no surprise that they are now regularly used on large commercial contracts. They are ideal for use in high-rise installations as they can be pumped onto several floors simultaneously, as was the case with the Shard in London. Anhydrite screeds have a low manufacturing carbon footprint and can offer a saving in excess of 95% of the carbon emissions associated with the manufacture of traditional sand cement screeds. Because anhydrite screeds can be used at significantly thinner depths than traditional screeds, they reduce the level of embodied energy by simply reducing the amount of building materials used. For example, in a block of 2-storey apartments, a total of 75 mm in the floor screed depth is achievable, meaning that 1 full course of bricks can be eliminated. The more floors there are, the bigger these savings become. Anhydrite screeds can be 100% recyclable, which has a significant impact on the lifetime analysis of the building. Where underfloor heating is incorporated in the screed, the high thermal capacity and high thermal conductivity of anhydrite screeds mean a fast response to ambient temperature changes. They can offer thermal conductivity as high as 2.5 watts per meter Kelvin. The average is 2.3 watts per meter Kelvin, compared to a typical value of only 1.1 watts per meter Kelvin for a traditional sand cement screed. Add this to the fact that the screed is thinner, giving a reduced mass and more intimate contact with the heating conduits. The result is an underfloor heating system which has an extremely rapid response and can run at temperatures significantly lower than competing systems. The opportunity to incorporate increased insulation depth further enhances the floor's thermal performance, resulting in a floor that offers a very high coefficient of performance. Generally, anhydrite binders are manufactured from a byproduct of the chemical industry, which would previously have been sent to landfill. As an example, every ton of binder used can mean that 0.98 tons of landfill is avoided, and for every 4 tons of gypsum waste removed from the landfill cycle, 1 ton of hydrogen sulfide gas is avoided. It is also worth noting that anhydrite screeds do not emit volatile organic compounds. Anhydrite screed binders do not contain Portland cement, and do not therefore contain chromium-6, which has a well-documented link to both acute and chronic health issues for those exposed to it. Installation of anhydrite screeds is performed using specialist pumping equipment and does not require the installer to be on his hands and knees. Anhydrite screeds are also fully self-compacting, reducing the impact on the musculoskeletal system. Based on the advantages offered by anhydrite screeds, it should be of no surprise that they are gaining in popularity. The volumes of sand cement screeds have only just returned to the levels achieved in 2008. On the other hand, there has been around a 40% increase in the volumes of anhydrite screeds installed between 2008 and 2016. In 2008, around 86,000 cubic meters of anhydrite screeds were installed, compared to 143,000 cubic meters in 2016. There are a number of disadvantages associated with tiling onto anhydrite screeds. Anhydrite screeds are not suitable for use in external or frequently wet areas unless a tanking membrane is applied. This is because the screed crystallizes and loses strength when wet. Additionally, flow-applied screeds cannot be applied to floors that have any significant falls due to the liquid nature of the screeds. Anhydrite screeds require an extended drying time before they are ready to receive a finished floor covering. Typically, sand cement screeds should be allowed to dry for a minimum of 21 days according to the recommendations contained within BS 5385 Part 3. Anhydrite screeds, however, should typically be allowed to dry for at least 1 day per millimeter thickness for up to 40 millimeters, and an additional 2 days per millimeter thickness above 40 millimeters. This will mean, for example, that a 60 millimeter screed will require a minimum of 80 days drying time. These times will rely on the on-site conditions being ideal and will be extended in moist environments. The drying process is covered in more detail in a later slide. Surface preparation. Application should be to the manufacturer's instructions by a suitably trained and qualified applicator. In all cases, ground-bearing concrete slabs should include a damp-proof membrane to protect against rising damp. Note that damp concrete bases, for example those with residual construction moisture, in direct contact with the screed can result in considerably extended drying times for a screed laid bonded or not isolated from that base. This may have a detrimental effect on the adhesion of the installed floor finish. Levels must be accurate to meet the requirements of the specification for the floor tiles being installed. Table 4 of British Standard BS 8204 Part 7 defines 3 classes of surface regularity: SR1, SR2 and SR3. If SR1 is not achieved, further work using a suitable levelling compound may be required before tiling installation can be undertaken. The surface regularity classes are based on the maximum possible departure from a 2 meter straight edge in contact with the floor and are given as SR1 3 mm, SR2 5 mm, SR3 10 mm. Very large pours of unbonded or floating construction with a dimension exceeding 40 meters without interruption, such as dividing walls, should have suitably formed bay joints of compressible material. This may be formed by a crack inducer or a full-depth saw cut as soon as the screed has hardened to form a bay joint. Any joints in the screed must be carried through to the tiled finish to prevent tiles cracking and debonding, and will affect the setting out and location of cut tiles. For floors where there is a distance greater than 2 meters between perimeter walls, columns or steps, joints should extend through the full depth of the screed and tiled finish to allow for small thermal and moisture movements. At the design stage, provision should be made for the thermal expansion of the screed and applied flooring. Both heated and unheated sections of screed, regardless of shape, must be separated by means of a joint. Movement joints should be inserted in doorways and where 2 rooms have separate heating circuits which are likely to be heated in different ways. The shape of the floor area should be taken into account to avoid cracking. This is best achieved by dividing such areas into rectangular panels separated by movement joints. Prior to tiling, the first issue that must be dealt with is to identify the screed type, as this will not be immediately apparent. Often a tiler arriving at a job may not know which type of screed has been used. Where refurbishment work is being undertaken, any previous floor finishes, adhesives or smoothing compounds may hide the nature of the screed beneath. However, there are ways to determine this. Anhydrite screeds tend to appear lighter in colour than a cement sand screed, sometimes almost white. When they have been laid properly, anhydrite screeds are smooth, not granular in appearance, as tends to be the case with cement sand screeds. There may be very few, if any, joints in the floor span because the product would most likely have been pumped in one pour and does not need any stress joints. If still in doubt, a chemical test can be carried out which will identify a high sulfate content, meaning this is an anhydrite screed. What are the different surface preparation requirements for traditional sand cement screeds and anhydrite screeds? In accordance with BS 5385 Part 3, sand cement screeds must be a minimum of 3 weeks old before tiling can commence. Although moisture will still be present in the screed, it will not affect a tiled finish. The main factor to be considered is shrinkage stresses during the initial drying stage. After 3 weeks, any major drying shrinkage in the screed will be finished, making it safe to receive a tiled finish. Before tiling commences, the levels of the screed should be checked, and if an SR1 surface regularity has not been achieved, then the screed would need to be levelled with a suitable levelling compound. Before the levelling or fixing process, all traces of surface dust, dirt or debris should be removed by dry brushing or vacuuming. The surface should be primed with an SBR diluted 1:4 with water to suppress the formation of any further dust and reduce the porosity of the screed, which may otherwise remove water from the adhesive too quickly, thus preventing it from achieving full cure. Tiles should be fixed in a suitable cement-based adhesive. On ground floor installations where there is no underfloor heating and it is not anticipated that the installation will be subjected to movement stresses, an adhesive with a C1 classification in accordance with BSEN 12004 may be used. On suspended floors or where there is underfloor heating installed, a C2 or C2S1 adhesive should be used. Other factors have to be taken into account before tiling onto anhydrite screeds. After they have been pumped, a weak latence or skin forms on the surface of the screed, which needs to be mechanically removed around 4 to 6 days after screeding using a suitable piece of equipment such as a sander or belt grinder. This opens up the surface of the screed and will therefore also aid the drying process. The minimum drying time for an anhydrite screed in ideal drying conditions, based upon temperatures of 20 degrees Celsius and 65% relative humidity, is quoted as 1 day per millimetre of screed thickness up to 40 millimetres, with an additional 2 days per millimetre screed thickness above 40 millimetres. It should be noted that the anhydrite screeds will absorb moisture from the atmosphere, for example from unventilated areas with poor airflow, high humidity areas, or even from wet plaster walls. It is therefore essential that good ventilation is ensured. The use of dehumidifiers can assist in reducing atmospheric humidity. Drying times will also increase in low temperatures. The drying rates of anhydrite screeds can also be improved by using room heaters and underfloor heating if it has been installed, although care must be taken that the heating is commissioned in accordance with the instructions of the manufacturer and be brought up to speed slowly. The screed must be dried to achieve a relative humidity not greater than 75%. Once dry, the screed should be primed and sealed with a suitable product such as an SBR primer. An initial coat of SBR diluted to 1:4 with water should be applied to the screed. This will reduce the screed's porosity and suppress dust. Once dry, a second coat of SBR diluted to 1:3 with water will need to be applied and allowed to dry. If the screed is still porous, then a third and final coat of SBR diluted 1:2 with water will be required. Once the primer has dried, tiles may be fixed in a suitable C2 or C2S1 cement-based adhesive. It is critical that the screed is prepared correctly, as failure to seal correctly will lead to the formation of ettringite, covered in a later slide, and ultimately tiles debonding. In the previous slide, we made reference to the types of adhesives which are suitable for fixing tiles to both sand cement and anhydrite screeds. Now we will have a brief look at how the adhesives are classified. BSEN 12004, Adhesives for Tiles, Definitions and Specifications, is the current industry standard. C indicates cement-based tile adhesives and is the group that is relevant to today's presentation. There are two further groups defined by BSEN 12004, which are D is for dispersion-based or ready-mixed, R denotes reaction resin-based. These are further subdivided into 1. Normal adhesive. This classification is suitable for solid substrates which will not be subjected to movement stresses. 2. Improved adhesive. This classification is generally highly polymer modified for additional tensile strength and is suitable for use on floors which may be subject to limited movement stresses, such as heated floors, suspended floors, and strengthened timber floors. F. Fast setting. This is the preferred option for floors, allowing them to be trafficked early, enabling fast-track installation. Other subdivisions are T for reduced slip, E for extended open time. Finally, S is for transverse deformation, which is defined in BSEN 12002. This is a measurement of how much the adhesive or grout is able to distort under stress. The most common designation is S1, 2.5 to 5 mm. There is a further designation of S2, which has a deformability of greater than or equal to 5 mm, but is not widely specified or required. Given the disadvantages and the extra work needed when using cement-based adhesives, some tile fixers see working with calcium sulfate screeds as time-consuming and prone to problems. However, this need not be the case if the correct procedures are followed. As covered in an earlier slide, a chemical reaction in the form of an expansile crystal known as ettringite occurs between gypsum in the screed and cement in the adhesive. This results in tiles loosening and debonding, with failure occurring at the screed and adhesive interface. This risk can be eliminated by using a gypsum-based adhesive instead of the more common cement-based adhesive. By using gypsum-based adhesives, tiling may commence slightly earlier when the screed has achieved a relative humidity of not greater than 85% instead of the 75% required when fixing with a cement-based adhesive. As can be seen, the use of a gypsum-based adhesive reduces the amount of preparation required before tiling can commence. When using a cement-based adhesive, it is essential that the screed is not only primed, but also fully sealed to prevent ettringite formation. The use of a gypsum-based adhesive means that only a priming coat is required to reduce porosity and suppress dust formation. Once this primer coat has dried, tiles may be fixed. The use of a new innovative preparation system has now made it possible to tile onto anhydrite screeds using a cement-based adhesive after only 8 days irrespective of the screed thickness, once the screed has achieved a relative humidity of 95% as shown on the graph. This offers an advantage over sand cement screeds with a minimum drying time of 21 days, and cuts the minimum stated time of a 40 mm thick anhydrite screed by at least 32 days and an 80 mm screed by a massive 72 days, reducing the build time by at least 10 weeks. There are 3 different steps to the system as follows. Step 1 uses a 2-part water-based resin primer applied to the floor 7 days after the screed has been pumped. This penetrates into the screed, binding it together and strengthening it. The primer also reacts with residual water present in the screed, therefore reducing the amount of free water. Step 2 introduces a moisture suppressant, which does not cap the screed, potentially weakening its structure. Instead, it allows the escape of residual moisture in a controlled way, which does not pose any risk to the screed or adversely affect the finished floor covering. Step 3 is a gritted primer, which provides a key onto which the ceramic tile adhesive can form a strong bond, ensuring that tiles stay where they should be throughout the entire life of the installation, adhered to the floor. The bond strengths can be demonstrated by the tensile adhesion strengths achieved when porcelain tiles are fixed to a 40 mm thick anhydrite screed in on-site conditions. The tensile adhesion strengths of each porcelain tile sample, cut to 50 mm by 50 mm and tested using a pull-off apparatus in accordance with EN 1348, were all greater than the minimum requirement quoted for a C2 adhesive of 1 newtons per millimeter squared. In fact, 90 days after tiles had been fixed, a screed tile just 8 days after the screed had been pumped achieved a mean tensile strength 63% higher than the required minimum, which further increased 94% 180 days after tiling. The blue column shows the required tensile adhesion strength in newtons per millimeter squared for a C2 adhesive on a standard concrete slab, 1 newton per millimeter squared. The orange column is the mean tensile adhesion strength achieved 90 days after fixing onto a 7-day-old anhydrite screed, 1.63 newtons per millimeter squared. The pink column shows the increase in mean tensile adhesion strength 180 days after fixing onto a 7-day-old screed, 2.05 newtons per millimeter squared. The green column shows the mean tensile strength achieved 90 days after tiling onto a 14-day-old anhydrite screed. As can be seen from the final red column, the mean tensile strength of 1.36 newtons per millimeter squared achieved 90 days after tiling onto a 14-day-old screed remains the same 180 days after tiling onto the same age screed. Let us recap on the preparation required for the 3 different approaches to tiling anhydrite screeds. For all options, the screed requires sanding. However, this only needs to be a light sanding when a gypsum-based adhesive or the fast-track option is used. Using traditional cement-based adhesives, the screed must achieve a maximum relative humidity of 75% in ideal drying conditions. Based upon 20 degrees Celsius and 65% relative humidity, the minimum drying times quoted are 1 day per millimeter thickness up to 40 millimeters, with an additional 2 days per millimeter above 40 millimeters. This means that a 40 millimeter screed will have a minimum drying time of 40 days, increasing to 80 days for a 60 millimeter thick screed. It should be noted that ideal conditions are rarely encountered on building sites. Additionally, anhydrite screeds will absorb moisture from the atmosphere. It is not uncommon for the relative humidity of a screed to increase during the plastering process or when ventilation within the room is limited, such as when windows and doors are closed. It has been known for anhydrite screeds to be too wet to receive a finished covering for some 6 to 12 months after laying. Once dry, the screed needs to be primed and sealed to reduce absorption and prevent ettringite formation. When it is intended to fix tiles using a gypsum-based adhesive, the screed will be suitable to tile once it has achieved a maximum relative humidity of 85%, offering a small improvement in the time it should take to achieve this. The screed only needs to be primed to suppress dust and reduce its porosity. Because the adhesive contains gypsum and not cement, the potential for failure due to ettringite formation is removed, meaning that it is not necessary to seal the screed. The fast-track system enables the screed to be primed just 7 days after it has been laid, once it has achieved a relative humidity of not greater than 95%. After the 2 coats of primer have been applied and dried, 2 coats of moisture suppressant are applied by roller and allowed to dry before the gritted primer is applied to provide a key for the recommended C2 cement-based adhesive to bond to. This means that around 8 days after installing, the screed is ready to receive a tiled finish. Let's have a look at an exciting London-based development where the new fast-track system is being successfully used. On the bank of the River Thames by the Tower of London, Sugar Quay is a prestigious new development by a major house builder. Working closely with a leading manufacturer of anhydrite screeds, full on-site trials were performed on a new fast-track solution to tiling anhydrite screeds. The system offered major cost savings to the builder, enabling tiling to be performed just 7 days after the screed had been laid. It also allowed floors to be tiled before the underfloor heating system was commissioned without any detrimental effect on the finished surface. This is a major positive, as commissioning of underfloor heating can add delays of anything from 14 to 28 days before tiling can commence, and obviously cannot be performed until the surfaces and boiler are connected up. The trials were monitored and assessed by the house builder and an independent body, and were successful, resulting in the system being used on site. Let's summarize what we've learned today. By now, you will understand the differences between sand cement and anhydrite screeds, including the advantages and disadvantages of each. You should also now have knowledge of the processes for installation of each type of screed, with regard to the relevant British standards as well as the subsequent drying times, preparation of the screed, and correct tile adhesives, enabling you to specify a safe, guaranteed, industry-approved system which allows fast-track fixing to anhydrite screeds. Here is a short list of further references. Norcross Adhesives are always happy to provide specification support and advice at any stage of a project. Should you require any further information on any aspect we've spoken about in this seminar, please contact our specification advice line on 0870 609 2851 or email technical@norcross-adhesives.com.